Hello everyone. So welcome to today's session. So we can start the class now. So let me open my Notion.so notebook. Then we can proceed on from where we left off last time. So from our discussions, so this is what we've discussed so far. So let me note them down. Then we can proceed on from there. We've already looked at the introduction to supervised learning models. And for supervised learning models, we have regression models. And apart from regression models, we have classification models. So for regression, we've looked at linear regression. So I can indicate that as R. We've looked at lasso and ridge regression also. Then for classification, we've looked at logistic regression. So I'll type in LGR to represent logistic regression. And here you've known that for supervised learning models, we work with data that has labels. So when it comes to the other types of model that we are going to look at, so for example, the unsupervised models, we are going to look at data that has no labels. And what I'll do is I'll use the diabetes dataset that I shared with you to illustrate this. So yeah, this is just a summary of what we've covered so far. So we've covered regression and we've covered classification models. So what we are going to look at next is the unsupervised learning models and how do we work with these unsupervised models. So let me open my notes on that and then we can proceed. Okay, so here we've looked at classification models. So for classification models, we've only looked at logistic regression models. So I guess before we go into unsupervised learning models, whereby we have clustering, let us have a look at the KNN model. So see how the KNN model works. So that will be our discussion for today. So the KNN model. And tomorrow we will look at decision tree and random forest combined before we can have a look at clustering models. So this will be the end of, so we've already covered machine learning 1. So we are coming to, this is machine learning part 2. So advanced machine learning 1, advanced machine learning 2. So this will be the other course that I guess people who are handling business intelligence won't have a look at. So yeah, let's discuss what we have for today. Let me remove all this, then I can type in things you need to understand for a nearest neighbor. So already you've learned that for logistic regression models, we work with probabilities, right? So for logistic regression models, we work with probabilities. So if something is greater than 0.5, so we have a threshold. So for example, 0.5. When it comes to k and n, so k nearest neighbors, so we work with distance, okay? And when I say distance, so what I mean is who is the nearest neighbor. Okay. So for example, if we had this circle and we had this other bigger circle, and let's say we had, so maybe I can change the color for this. Let's say we had data points here. So for example, that X, that X, and that X, and that X, and that X. Then I add some other data points. So for example, that circle, that circle, that circle there. Okay. And maybe a single circle out here. And let's say we have this class here. And that class is for someone who is diabetic, okay? And this other class here, which is class X, is for a non-diabetic person. And let's say, for example, we had two numbers here. So we had the number 3 and we had the number 6. And these numbers here can be represented as n. So this is our n here. And what does n stand for? So n should be equals to the number of neighbors, okay? So when it comes to such kind of situations when dealing with k and n, so if n is equals to 3, so what we will look for is in between this bigger circle, do we have a smaller circle? And yes, you can see we have a smaller circle in here. And here we have two classes. So for these two classes, what are the number of observations we have for each class? So for example, for this class diabetic here, we have 1, 2, 3, 4. We have 4 observations. For class X, which is non-diabetic, we have 1, 2, 3, 4, 5. We have 5 observations. So when we are looking at this n, which represents the number of neighbors that we are looking at, we will be considering the lowest and the highest number. So when n is equals to 3, when the number of neighbors is equals to 3, then we will consider the class with the lowest number of inputs. So for example, diabetic has the lowest number of inputs. So this will be for a person who is diabetic. So diabetic should be D, non-diabetic should be ND, something like that. And for class 6, so when the number of neighbors are 6, we go with the class with the higher number. So this will be non-diabetic. So let's go through the theory and see what is mentioned there. So K nearest neighbor. So K nearest neighbor, KNN, is a supervised machine learning algorithm used for classification and regression. So one thing you need to note is KNN can be used for both classification and regression. The basic idea behind the KNN algorithm is to find the K number of points in the training dataset that are closest to the point we want to classify or predict. The algorithm then assigns the most common class or mean value of the k closest points to the point where we want to classify. So for example, we can predict a 3 or a 6. So here you can see we have two circles. So if it is class 3, then here I will say it's a red. If our value is at 6, I will say it's a square. So something like that. So let's go ahead and work with the data that I had shared with you guys. And then, yeah, we can see how the model works. So what I'll do here is I'll create a new notebook, and the notebook will be diabetes, then ANN, so that will be our notebook for today. So let me zoom in so that you can see what I'm working on, and then we can start from there. So what I'll do is I'll start by importing libraries that we need. So we will start with import pandas as PD for reading the data, then import, we actually don't need numpy, so we only need pandas for now. Then I will read in my data. So my data has been stored as diabetes.csv. So I will have df being equal to pd.read underscore diabetes.csv. So I think I should change the theme that I am using here. So let me see. Don't know if you can see my code better now. So I think should be better now. Yeah. So let's proceed. Then we are to print out the top 5 rows. So this is the code to import the data. So I believe you have the data downloaded, and on your side you have it imported. So today I'll skip the EDA part and we will go directly into the machine learning part. Okay, so this is our data. So we have a few columns here. So what I'm going to do is I'm going to print the column info. So we are going to have to get the data info. So you're going to have df.info. Yeah, so this is what we have. So the good thing is all the columns that we have here are of type float. So we don't have to do any changes for our data set. Then what we can see here is we have 25,680 entries. So what we need to confirm is none of our columns has missing values. And checking from the total entries that we have here, you can see that all the columns that are here have the same matching number, so which is 25,3680. So what we can confirm again is if our data has duplicates, and that will be in the next step. So because we are fitting a classification model, so what we need to identify first is our target column. So what's our target column? If we go back to Kaggle, you can see the column details. So here, I think diabetes 012 is our target column. So here you can see 0 no diabetes, 1 pre-diabetes, 2 diabetes. So we are going to make a model that predicts 3 different outcomes. So is a person not diabetic, is a person pre-diabetic, or is a person diabetic? So That's what our target column is telling us. So let's proceed on with our code and check if data has duplicates. So here we are going to check for duplicates because our data has no missing values. And if we check for duplicates, you can see we have 23,899 duplicates which we need to drop. So this is the code that we use for checking for duplicates. So df.duplicated.sum. That's what we use all the time. Okay, so let's proceed. So what I'll do is I'll drop duplicates. So here we have df.drop underscore duplicates, then in place equals to true, meaning that we are going to remove those columns permanently. And I'm going to check for duplicates again, and I'm going to see if my data has duplicates. But before that, I'm going to do something like df.size. So yeah, we have, okay, let's do df.shape instead. Yeah, so these are the rows we have. So what I'll do here, instead of checking for duplicates, I'm going to check the shape again to see how many rows we have left. So I've dropped the duplicates and the number of rows have reduced. Okay, so that's it for the first part of pre-processing the data. So any questions on that so far? Okay, so if no questions, I guess we can proceed. So I'll go slow from here so that you can copy the code that I'm typing in. So this will be the ML part. To be specific, we are fitting a KNN model. So what we will do first is we will split data into target and features. So we will have our X being equal to df dot drop. Then we will drop the diabetes 012 column, and axis should be equal to 1. Then we will have our Y being equal to the diabetes 012 column itself. Then another thing I'm going to introduce today is the split of the data into training and test set. So why do we split data into training and test set? So we split the data into training and test set so that we can, so I think I'll include the markdown here. So it will be in terms of a question. So why do we split data into training and test set? So we split the data into training and test set. So you don't have to write this theory, but because you'll have access to it when I share the notebook. So we split the data into training and test set to avoid overfitting. So if we train the model on the same data, we test it on, the model will be able to predict the test data with high accuracy. So remember when we were fitting the model, we were fitting it on X, and also we were testing it on X. So which means that we are testing the model on data that it has already seen. We are not testing it on data that it has not seen. So what we need to do is we need to create a test set. So a test set is data set that the model has not yet seen. And this will be able to inform us, like, is the model performing better on data that it has not seen, or is it performing worse? Okay, yeah. So that's the reason as to why we always split the data into training and test set. So however, it will not be able to predict new data with the same accuracy. Okay, so I've included the theory there. So how do we split the data into training and test set? So you can use NumPy, but we have an inbuilt library in sklearn called train test split, and we can use train test split to do that. So what do we do? So we run from sklearn.preprocessing, okay, sorry, dot model selection, import train test split. Okay, so this is the library you import. Then you use these train test split functions to fill in the value of x test, x train, y train, and y test. And why are we doing it in this form? So remember, in the basics of Python class, so if we had a value q, comma r, we could assign it values by the use of a comma. So for example, we could say q should be equals to 10, comma, r will be equal to 23, for example. And if we print out the values, so for example, print q and then print r, you could see q will take the value 10 and r will take the value 23. So basically, this is the same thing that's happening here. So we have the function train test split, which takes in the value x and y. So remember, x is our features and y is our target variable. Then here we specify the test size. So the test size ranges from 0 to 1. So here where we have 0.2, it means that we are splitting the data into 80% training set and 20% test set. So maybe I can change this to 0.3. So we will have 30% as the test set and 70% as the training set. Then random state being equal to 42. So random state, you can use any value. So what random state does is it ensures that the values I am getting on my side are the same values that you are getting on your side, because the split here is random. Okay, so yeah, random state ensures that the values I'm getting on my side are the same values that you are getting on your side. That is if you are using 42 on your side as well. So hope that explanation is enough. Let me share this in the chat section and then we can proceed. So you can copy that and then we can proceed. So I've already explained this part. So if I print them out, you can see Q is equivalent to 10, R is equivalent to 23. So before we proceed, what I can do here is I can print the size of the train and test set dataset. So here we have xtrain.shape and then we have xtest.shape. So this will confirm if we've split the data into 70-30%. Or what we can do again is we can print the percentages. Okay. Okay, so let's not do that. So we will just work with the dot shape part here. And what I can add is, okay, so I think we can use commas here. And instead of x, we can just have x dot shape. So we compare xtrain, xtest, and the original data. So let's run that before we can proceed. Yeah, so that's what we have. So this is the preparation part for our model. So you can see xtest has 160,000 values. Then xtest has 68,000 values. And the original dataset had 229,000 values. So it means that we've successfully split this data into training and test set. So let's proceed. So I see I have errors here. Yeah, but these are things you don't have to worry about. Let's proceed. So the next thing we are going to do, so should I give you more time to copy this? So I'll give you 4 minutes to copy these and then we can proceed. So I'll also share it in the chat. Okay, so copy that. Then in the next few minutes, we are going to proceed. Okay, so I think we can proceed. And the next part will be to feed the KNN model. So what we are going to do is we are going to import the KNN classifier model, and we will have this from sklearn.neighbors import kneighbors classifier. So after importing the model, what do we do next? So we instantiate the model. So we will have knn being equals to k neighbors classifier. Then we must specify the number of neighbors. So as n underscore neighbors. So remember when we were discussing the nodes, so I showed you this part here where we have to specify the number of neighbors. So if we stated that the number of neighbors were 3, then we will have a different outcome. And if we say that the number of neighbors were 6, then we will get a different outcome. So here we have to specify the initial number of neighbors, and maybe I can say let that be 6. And then what we are going to do is we are going to feed the model to the training data. So here we'll be having knn.feed xtrain, ytrain. And we've created our xtrain and our ytrain up here. Then what we are going to do is we are going to predict on the test data. So now we are not predicting on the training data, we are predicting on the test data. So here we will have our ypred being equal to knn.predict. Then we predict on the x test. So we can run that. And lastly, what we can do is we can create our classification report. So from sklearn.metrics, import classification report. Then we are going to print classification report. We pass in our y-test and our ypred. So here we are working with only test dataset. So this will take a few minutes to run because we are working with a bigger model, and I guess it's done. So we can print out our classification report and see how the model works. So here you can see that the model is 82% accurate. Okay. And what we can see here is for non-diabetes, it has 84% accuracy in predicting this. So for pre-diabetic, it has 7% accuracy. Then for diabetic, it has 42% accuracy. So if we check the F1 score, we can say that. So F1 score is a combination of precision and recall. we can say that the model has an accuracy of 90% in predicting non-diabetic classes, 0% in predicting pre-diabetic, and 21% accuracy in predicting diabetic instances. So that's what we have, and that's how we fit a k-neighbors classifier model. So let's see if I change this value from 6 to 3, let's see how it affects the model accuracy. So the model was 82% accurate and 21% accurate in predicting diabetic instances. So let's see how that changes if we change the number of neighbors to be equal to 3. So it should have a high impact on the accuracy score, because these number of neighbors that we have here almost match the classes that we have here. So now you can see this is 89% accurate and this is 27% accurate. So this is an improvement of what we had last time. So you can copy these, and yeah, then we can proceed on from that. So I show you one last thing that you can do. And the last thing that I can show you is how do you pick the best n value. So let me share this in the chat and then we can do that. So actually choosing the best n value, we will just need to use a for loop, and we are going to feed this model for, we're going to make like 10 feeds for this model, and then we are going to pick the k with the best score. That's how we select the best number of neighbors value. Yeah, so 5 minutes or 4 minutes, you copy these and run it, and then we can finish, we can wind up the class for today. Okay, so let's proceed. So here I'll add a new code cell and then we will add the code to pick the best number of neighbors value. Okay, so what we will have here is we will use the accuracy score and then we will use a for loop to get the model with the best accuracy score. So here we will have AC representing accuracy being an empty list. So we will plot them and then we will run a model with number of neighbors from 1 to 10. So you already know how to you work with for loops for that. So with for I in range 1 to 11, feed each model and then append the accuracy score here. And then what we can do is we can plot the accuracy score for different n values. So basically that's what we have. So let me share this code in the chat section and then you can fit it on your side also. So this is self-explanatory. So you've already covered for loops in the basics of Python class, and also you've already covered the part for doing visualizations in the basics of Python class. So let's run that and give it time to see what kind of plot we will get and what kind of accuracies we will get for our model. So this is part of model tuning. So hyperparameter tuning to get the best hyperparameter for the model that gives the best accuracy. And the hyperparameter that we are tuning over here is the number of neighbors. So for this to give us the best number of neighbors here, that will give us the best accuracy when we are working with our y-test and our y-pred data. So actually another thing we can do is we can compare the performance of our model on both the test and the trained dataset and see if it's true that the accuracy will be different for the test and the trained dataset. So this should take around 2 minutes to run, depending on your PC power. So it might take 2 to 3 minutes to run. So the more numbers you have here, the more time it will take for this model to run. Okay, so the model is still running and it's past 3 minutes, so we should give it more time to run and see the output that we will get. Hi. Okay, so can you check that your N, and C are capital letters? So the for loop is saying that K and N has not been defined. So what you can do is you can copy the code for importing K and N from up there and paste it down there instead. So include it in your code cell also. Yep. So this is the output we get. And you can see that with every fit, the accuracy changes. So with the number of neighbors being one, we get an accuracy of around 75%. Yes, Almasi.
Oh, I have a question.
Yes, you can ask.
Yeah, I was missing a little bit because of the network. So, what does it mean when the precision when the accuracy score returns one?
It means that your model is 100% accurate.
Is that possible? 'Cause
Yeah,
I've tried numbers to still brings one.
yeah, it can be possible. Because remember when we
Yeah.
fitted a random forest model on our data set, we had an accuracy that was 100%. So it's possible depending on the power of your model and the complexity of the data that you have.
So, what brings about the difference? Because you got 82, I'm getting 100.
So which model did you fit? And are you checking the accuracy on the test set or the
Okay,
train set?
okay, man. I missed your code because the network keeps on
Yeah,
going
and
on and off.
that's the reason as to why I mentioned that this part here. We split the data into training and test set to avoid overfitting. So we use the train set to confirm if the data is overfitting. So what I can do on my side and for others is here when we are training the model is so for example I'll use the number of neighbors that gives us the highest accuracy, so it's 10. So I'll change these to 10 up here and
Can
then
I
I
repeat?
can fit the model. So you've used 5, and did you do this part for train test split? Okay, let me use 5. Then for predict you've used X train instead. For this Y pred should be you've used knn.predict, you've used X test. And then if you run your classification report, you get 100% accuracy.
Yes.
Mine is at 0.83.
Okay.
Yeah. So what I wanted to show you guys is I can compare these again with the training set. So I will have classification report, then Y train, and then knn.predict X train. And you'll get to see the different scores that we will have. So it's running. Let's give it a few minutes and then we can see the output results. Okay, so it's taking long to run. Not sure why, but let me copy the code where we have the X train and share it here with you so that you can check. Okay, so let me restart my. Okay, cancel. So I've cancelled. So here you can see we have the results for X-train. So these first results here are for X test. So 0.83% accurate. But when I use X-train, we get 0.84% accuracy. So which means that when we test the model using the test set, we get a lower accuracy, but the accuracy is close also to what we have when we are testing the model on the trained dataset. So this means that the model is not overfitting or underfitting. So if the test accuracy was high and the accuracy was low, then we will say the model is underfitting. And if the test accuracy was low and the train accuracy was high, we will say the model was overfitting. So that's basically all you have to understand for today. So we will discuss more as we learn even more. So any questions concerning what we've covered today? Any questions? So I'll stop the class recording there for today.
Can I ask a question?
Yes, you can ask.